In this video, we're comparing the cylindrical transformation to disk method. Here, we're assuming that R and Z are independent of theta, and theta is independent of R and Z. If you look at the picture on the right, it's the ice cream cone picture, and on the left is that ice cream cone in theta, R, and Z. Again, when you're computing triple integral with cylindrical transformations, you can do more than volume versus disk. That was entirely just computing the volume. Disk method, that was entirely computing the volume. Now, when does cylindrical transformation compare to disk analogy? When you decide to integrate with respect to R before Z. Since theta is independent from R and Z, you can move the integration with respect to theta to the most inner and the middle, or the most outer. It doesn't matter. The other two are the ones that are related to each other and make interesting pictures. So let's look at this interesting picture that they make. R and Z are making with respect to each other, and then start to take the integral, set the bounds, so R goes first. If R goes first, those two lines in there, the red and the green on the bottom in the cone part, are the arrows that we typically draw for the two different regions. In each region, those arrows correspond to a rectangular prism, a thin rectangular prism, because their height is infinitesimal. So, and they represent the volume of that thin rectangular prism. And then after the transformation, let's look at this. Here, the red goes from 0 to this surface of the ice cream, basically, and that's the different values that R can take, and that transforms to the disk over here from 0 to the end point of the cone, and the one for the cone also transforms into another disk. And this is how the comparison works.